This video is going to talk about why mobile homes are dangerous in a hurricane, and it's going to go beyond the obvious fact that a mobile home is light and it can blow away fast. It's going to go into a principle of fluid dynamics. So what is fluid dynamics? Well, fluid dynamics is dealing with the motion of air, or a fluid. In this case, air is the fluid, dynamics is the motion. And we're going to deal with something called Bernoulli's principle. And Bernoulli's principle is important because it's what allows an airplane wing to get lift. And Bernoulli's principle is a very clever way of talking about conservation of energy. So, for example, conservation of energy just says that the energy initial equals the energy final in a system, and we know that that's going to be kinetic and potential energy. Initial potential and initial kinetic is going to equal final kinetic plus final potential. Bernoulli's equation is just another way to say that, but we're going to be dealing with fluids. So we're going to say that the pressure on one side plus 1/2 rho v squared plus rho gh, or rho gy, if you want to say it, equals the pressure on the second side plus 1/2 rho v squared plus rho gy on the other side. And this is the two here. This is side one. So what is that really saying? That's basically saying conservation of energy. This is the kinetic term, this is the potential term, and these difference of pressures would be what we would call a non-conservative term, which could go into there. Okay, which we don't talk about unless we're dealing with outside influences. But how does this affect mobile homes in a hurricane? Well, to first understand this, we need to understand the concept of lift. Okay, lift in a storm. So basically what's going on here is that when you have an airplane wing, okay, let's just say you have an airplane wing like this, and the wing looks like this, okay, what's going to happen is as the wind comes across that wing, it's going to have to travel further on this side than on this side. So it's going to have to travel at a higher speed on this side than on this side. So if we take a look back to Bernoulli's equation, we can basically bring that all over to one side and say, okay, the change of the pressure plus 1/2 rho v2 squared minus v1 squared, plus rho g delta y equals 0. What that basically says is that as long as my height doesn't change here, that the pressure and the speed are going to be inversely related. So as the speed increases, the change of the pressure is going to go down. Okay? So what that means in terms of the airplane and lift on a wing is this. As a particle moves faster on the top here, okay, these particles are going to be more spread out. And as they're more spread out, there's going to be less pressure. On the bottom, there's going to be more pressure because it's moving slower. Okay? What happens is, if you have more pressure on the bottom than pressure on the top, okay, what's going to happen is you're going to get a differential that's going to cause a net pressure up like this. Okay, and that's going to cause what we would call on an airplane lift. Okay, now how does that affect a mobile home in a storm? Well, if you have a home, okay, let's just have like a mobile home here. And let's say that it's on some blocks here. Maybe it's tied down or strapped down with a strap or something like that. I don't know. But let's say that your wind is coming, and it's coming from, let's have it come from this direction this time. Your wind is obviously going to blow on these structures to make them blow over, right, just on their own. But what's going to happen is the wind is also going to go across the top of the roof here, and the wind is not going to really be able to go on the bottom here as much. So it's going to create the similar effect that you have on an airplane. We have less pressure on the top because there's less particle density here per unit space, and on the bottom there's more, and so it creates a pressure here on the home, and that creates lift. and that's going to cause the home to not only be pushed from the side, but it's going to cause it to want to go this way in terms of the net force, and it's going to cause that that home to topple over much easier than it would be if it didn't have that pressure differential. So it's the same concept that makes lift on an airplane wing, and that's going back to Bernoulli's equation, which is really just another form of energy conservation.